Hi everyone, this is Dr. G. Ravindranath Reddy working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So we are discussing the course of numerical methods and integral transforms. In that course, we are at the Fourier transforms. In that Fourier transforms, we are discussing finite Fourier transforms. Now in this video, we will discuss finite Fourier sine transform formula and Fourier cosine transform formula and problems on these two concepts we are going to discuss here. So first we will take infinite Fourier sine transform here. So in the previous video we have discussed infinite Fourier sine transform, and in this video we are discussing a finite Fourier sine transform. Whenever we want to apply that finite Fourier sine transform or finite Fourier cosine transform, in the problem along with the function we have to get some initial condition. In general, that initial condition we will consider as 0 less than x less than L. Okay, you will get the while you are taking the problems, sometimes you may get 0 less than x less than 2. That is, our interval is 0 comma 2. So by comparing this, we have to get L is equal to compare this L value, compare these two intervals and get the value of L and substitute that value here in this formula. So Fourier sine transform of f of x is given as 0 to L. That L value you may get from in the problem. In general, we will represent that finite interval as 0 comma L. So f of x into sine n pi x by L into dx, which is represented with f suffix s of n. So in the infinite we have taken that value as f suffix s of p, but here in the finite we are taking that for integral value as f suffix s of n. So where n is some integer value here. Now inverse Fourier sine transform, which is represented as f suffix s of n, is given by f of x is equal to 2 by L summation n is equal to 1 to infinity f suffix s of n into sine n pi x by L. Okay, and similarly we will take the finite Fourier cosine transform here. So in general, in this case also we will represent that finite interval as 0 comma L, and that in that interval 0 comma L, the finite Fourier cosine transform is given by integral 0 to L f of x into cos n pi x by L into dx. Okay, so that value is represented with f suffix c of n, and its inverse formula is given by, so integral 0 to f of x is equal to 2 by L summation n is equal to 1 to infinity. We can use this formula or we can use this formula here. Now let us take the problem here. Find the finite Fourier sine and cosine transform of f of x, where f of x is equal to 2x. So in the previous he has not given some interval like this, but here he has given the interval that is 0 less than x less than 2 pi. 2 pi is some finite value here. So whenever by using this interval which is given in the problem, we have to decide whether it is a finite or infinite. In blindly we can say that in this interval we don't have the infinity, so we have to consider that interval is a finite. Okay, now we have to find out both Fourier sine transform, finite Fourier sine and cosine transform for the function f of x is equal to 2x. So this is the formula we have taken to find out the finite Fourier sine transform. Now replace f of x with 2x, and the limits, our standard limits are represented with 0 less than x less than L. Now compare these two. In place of L, here we are having 2 pi. So in this formula, wherever we are having L, so we can replace that L with 2 pi. So we can get our required formula, integral 0 to L. Here we are having L, so we have to replace that L with 2 pi. F of x, replace that f of x value 2x, sine n pi x by, so here we are having sine n pi x by L. L is 2 pi. So this pi gets cancelled. You will get sine nx by 2. This is the value. 2 is constant, so we can take the 2 outside. So you will get 2 into integral 0 to 2 pi x into sine nx by 2 into dx. Apply UV formula here. So this is the value we get for integral of that. Now substitute the limits 0 to 2 pi. So you will get this value here. Sin n pi is 0. Cos n pi we can consider as minus 1 whole to the power of n. Substitute this. Finally you will get this value. So this sin n pi, you will get this sin n pi is equal to 0. So already here we are having minus. So if we replace cos n pi with minus 1 whole to the power of n. So here minus, already here we are having one more minus. You bring this minus to here, it becomes minus 1 whole to the power of n plus 1, which is our Fourier sine transform of f of x in the interval 0 less than x less than 2 pi. Now similarly take this cosine transform value, replace that f of x and compare that the integral limits 0 less than x less than L with 0 less than x less than 2 pi. This is our standard interval and this is the given interval in the problem. So if we compare this, you will get L is equal to 2 pi. So replace that, you will get this value and apply integral of UV formula. So substitute the upper limit and lower limit here in place of x. So we will get our value here. So 8 by n square minus 1 whole to the power of n into minus 1. So we will consider this value as the finite Fourier cosine transform of that given function f of x. So now let us take some problems on the inverse finite cosine inverse formulas. Now inverse Fourier inverse finite cosine transform Fourier cosine transform of f of x. We have to find out that f of x and its value f suffix c of n value is given and the limits are 0 to 4, 0 less than x less than 4. You compare this 0 less than x less than L, so you will get L is equal to 4. So now for this function, otherwise we can say that we have to find out the value of f of x for this given Fourier cosine transform value. For this Fourier cosine transform, we have to find out f of x. In order to find out f of x, we have to apply inverse formula here. So take the inverse formula 1 by L f suffix c of 0 plus 2 by L summation n is equal to 1 to infinity. This substitute L is equal to 4 here. You will get 1 by 4 f suffix c of 0. You substitute say, so we got this value f suffix s f suffix c of n. Now we want f suffix c of 0. You will get this by substituting n is equal to 0 here. You will get cos 0. Cos 0 is 1 by 1 square. So 1 by 1 square, this can be written as 1. So that's why here this value is represented as 1. So 2 by 4 summation of n is equal to 1 to infinity. F suffix s of n, we can replace that value here. So after replacing f suffix s of n value and L value in this is our final, you will get here. Now if you want, we can expand n is equal to 1 by 1. So you will get 1 by 4 first term after taking n is equal to 1 plus second term by taking n is equal to 2, and you will get third term by taking n is equal to 3. So like this you can go up to infinity. Okay, so this is our in f of x value which is suitable whenever we apply the Fourier infinite Fourier cosine transform. This is the value we get. Now reverse, we got this, we are going to find out the function for which this value is suitable. So this is the function for which the finite Fourier cosine transform value is given. Now similarly finite sine transform of f of x where this value is given. So interval is 0 less than x less than pi, which is of the form 0 less than x less than L. You will get L is equal to pi. Now use that formula. This is the formula. Substitute L is equal to pi and replace the f suffix s of n with this value in the standard formula here. So you take, since our summation fixed for n, so this pi square becomes a constant, so we can take that pi square outside. So you will get 2 by pi cube. Summation n is equal to 1 to infinity, this value here. So this is the way how we can use these inverse formulas for both finite sine and cosine transform here. So in this we have seen finite, Fourier sine transform, finite Fourier cosine transform, and its inverse formulas. So we have taken this, then some examples here. So in the next video we are going to discuss about vector differentiation. So with this we can complete our Fourier transforms. In the next video we are going to discuss about vector calculus, which comes under vector differentiation, that is gradient. So how to find out the gradient, how to find out the divergence, and how to find out the curl of the vectors or scalars. So thank you.